Hello, today we're going to work on lesson 5-5. In our book it's on page 295 and we're going to be looking at graphing inequalities in two variables. I would like you to have your notebook to take some notes, but you also need your book because we're going to work on some graphs. So the graph of a linear inequality represents the set of all points that are solutions to the inequality. These are some of the things I want you taking notes on right now. So the edge of the graph is called the boundary. So that's, if I drew the line of the graph, this is the boundary. Depending on the inequality, the boundary will or will not be included in the solution set. Each side of the boundary is called a half plane. When the boundary line is included, the solution of the linear inequality is called a closed half plane. So I'm jumping down here. If we have the less than or equal to or greater than or equal to, that is going to be a closed half plane, and our line is going to be a solid line. This is closed. And then we also have the open half plane. That's going to be a dashed line, and that's going to use our less than and greater than symbols. That's going to be an open half plane. Then after we get our line graphed, we're going to use a test point to determine which half plane should be shaded. And then we're going to shade the half plane that contains the correct solution. Here I go to example 1. So we need to graph the inequality with the open half plane. So this is going to be an example of an open half plane. So here we have an inequality, and I want to get y by itself. So first I'm going to go minus 3x on both sides. I now have negative 2y is less than negative 3x plus 8. I still need to get y by itself, so I'm going to divide by negative 2. I'm going to divide everything by negative 2. This cancels and leaves me just y. I divided by a negative, so my sign is going to flip. Negative, negative cancels out, but I'm going to leave this a fraction. 3 over 2, bring down my x. And then 8 divided by negative 2 is going to be negative 4. So here's my line that I can now graph. Remember, this number is my y-intercept, so my y-intercept is negative 4. This is my slope, so rise over run, I'm going to go up 3 over to the right 2. So 1, 2, 3, 1, 2. If I do it again, it makes it easier to draw my line. 1, 2, 3, 1, 2. This does not have an equal sign underneath of it. This is just greater than, so this is going to be a dashed line. So I'm working with an open half plane. The next thing I have to do is I have to figure out which side to shade. In order to figure out which side to shade, I'm going to use a test point. When 0, 0 is in one of the planes, use 0, 0 as the test point. If I plug 0, 0 into this inequality, and it makes the inequality true, then I will shade the side with 0, 0. If I plug 0, 0 into this inequality, and the inequality is not true, then I would shade the other side. So remember that this is an x and this is a y. Let's plug them in and see what happens. I have 3 times 0 minus 2 times 0 is less than 8. Let's see if that's true. 3 times 0 is 0. Negative 2 times 0 is 0. 0 minus 0 is 0. Is less than 8. Is 0 less than 8? Yes, that is true. Because that is true, I'm going to shade, and I don't have a pencil, and shading with a pen is hard, so I'm going to use a highlighter. I'm going to shade this half of the half plane where my 0, 0 point is, because that means that this is the half that it has the solution set in it. It doesn't have to be perfect, but you can see this is my open half plane, and this is where all of my solutions lie. Moving on to example 2. Now I'm going to graph an inequality with a closed half plane. So here we go again. I need to get y by itself. I'm going to subtract 3x, subtract 3x. I have 4y is less than or equal to negative 3x. That's 0, so I do not need to bring it down. I do, however, need to get y by itself, so I'm going to divide by 4, divide by 4. Now I have y is less than or equal to, 3 cannot be divisible by 4, so I'm going to leave this as negative 3 over 4x. Now when I have no b, I don't have a y-intercept, but I do. It is just 0 and it's invisible. So my y-intercept is 0, so that means I'm going to start right here at 0. My slope is negative 3 over 4, so that means I'm going to go down 3. 1, 2, 3, to the right 4. 1, 2, 3, 4. I see that I have an is equal to, so less than or equal to symbol. So I'm going to use a solid line, and I'm going to draw a line straight through. Now I need to figure out which half to shade. I can't use 0, 0 as a test point because it falls on my line. So what I'm going to do is I'm going to use right here 1, 1 as a test point. So I'm going to plug in 1 for x and 1 for y. And if I do the math here and it is less than or equal to 0, then I will shade this side. If I do the math and it is not less than or equal to 0, I will shade this side. So 3 times 1 is 3. 4 times 1 is 4. 3 plus 4 is 7. Is 7 less than or equal to 0? No, it is false. Because it is false, I'm not going to shade this side, I'm going to shade this side. And that shows me that this is my closed half plane where all of my solutions lie. Next up is the check. You're going to pause the video here and you're going to work on the check on your own before you come and watch me work them out. So I'm going to rewrite these down here so it's easier to have room to work them out. I need to get y by itself, so I'm going to subtract 2x, subtract 2x. I now have y is less than negative 2x minus 4. Here's my y-intercept is negative 4. 1, 2, 3, 4. Here's something weird that I told you I would show you when we get there. This is negative 2 over an invisible 1. This is my slope. I don't have room on my graph to go down 2, right 1. So I'm actually going to move backwards, and I'm going to go up to left 1. I'm moving backwards. If this is confusing to you, raise your hand, and a teacher will come help you. Instead of going down 2 over 1 where there's no graph, I'm going to go up 2 to the left 1. I'm just working backwards. Up 2, left 1, up 2, left 1. This is still always down and right, but I had to work backwards. I see I don't have an is equal to with this symbol, so this is going to be a dashed line. So I'm going to make this dashed. And now I need to plug in a test point. I have 0, 0 here, so I can plug in 0, 0 and find out what my answer is. So I'm going to go here, I'm going to go 2 times 0 plus 0 is less than negative 4. Well, this is all 0, right? Is 0 less than negative 4? It is not. Negative 4 is smaller, so therefore this is not the side I'm going to shade. This is. So I'm going to go ahead and shade in this side. With that dashed line, that means anything on this line is not part of the answer, just the shaded portion is. Moving on to B, x minus 2y is greater than negative 4. This time I'm going to go minus x because I'm trying to get y by itself. I have negative 2y is greater than negative x minus 4. Still need to get y by itself, so I'm going to go divide by negative 2. Divide by negative 2. Y, flip my sign because I divided by a negative. Negative, negative cancels out, so this is going to be positive. There's an invisible 1 there. So I've got 1 over 2x. And then negative 4 divided by negative 2 is positive 2. So here I have my y-intercept is 2. 1, 2. My slope is up 1 to the right 2. So up 1 to the right 2. Up 1 to the right 2. I see this is going to be a dashed line, so I'm going to dash, 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 dash. And now I can use 0, 0 as my test point. 0, 0. All of this side is going to equal 0. Is 0 greater than negative 4? Yes, it is. 0 is greater than negative 4. So we're going to use the side with 0, 0 as the side that I shade that shows me my answer. I'm going to go all the way up to that line. It's a dashed line though, so the line itself does not have the solution set. Moving on to example 3. Here's our word problem for the day. Dominic can spend up to $20 to provide the dance squad with drinks after their practice. A bottle of water costs 80 cents and a sports drink costs $1.25. How many bottles of water and sports drinks can Dominic buy for the dance squad? So let's first write the inequality. So I've got 80 cents is how much a bottle of water costs, right? But do we know how many bottles of water they're going to buy? No. So I'm going to go 0.8x because I've got to figure out how many of those they're going to buy. They said we're going to add this together. We don't know how many, so plus $1.25 is how much sports drinks cost. And again, we don't know how many of those that they're going to buy, so I'm going to use y for that variable. But we do know how much money they have. They have $20 to spend. We cannot go over $20, so we're going to say this has to be less than the $20, or it can be equal to the $20. So here's our inequality. We're going to go ahead and solve that inequality with y, try to get y by itself. So I'm going to go minus 0.8x on both sides. Forgot the 0. Then I have 1.25y is less than or equal to negative 0.8x plus 20. I'm not done yet. I got to get y by itself. So I'm going to divide by 1.25, divide by 1.25. So y is less than or equal to negative 0.8 divided by 1.25 is going to be negative 0.64x. And then 20 divided by 1.25 is 16. So here's my inequality. That looks like it's a little bit harder to graph because of this slope. So while I can still use 16 as my y-intercept, it's going to be a little different. I would rather make a chart and figure out what my y values are. I know that if I plug in 0 for x, then this times 0 is 0, and all I'm left with is 16. So that goes to show that my y-intercept is 16. Now what I'm going to do is I'm going to take these x's and plug them in for x and do the math to figure out what y is. So pick up your calculator and do this with me. I'm going to plug in 10 for x, negative 0.64 times 10 plus 16 is going to give me 9.6. Let's graph that. Over 10, up 9.6, about right there. Do it again. Plug 15 in for x. Negative 0.64 times 15 plus 16. That's going to give me 6.4. I'm going to go there. I'm going to go 15 and then 6.4. And then the last one, I'm going to plug in 25 for x. So in the calculator, I'm going to go negative 0.64 times 25 plus 16. That gets me 0. So then over here on 25, I'm going to be on 0. This has an is equal to sign with it, so this is going to be a solid line. We almost missed my wonderful lines. I can't even do it on paper. I can still use my test point 0, 0. So if I go back to my original inequality, I make x 0, that's gone. I make y 0, that's gone. Is 0 less than or equal to 20? Yes, 0 is less than or equal to 20, so the test point 0, 0 works. And I'm going to fill in this underside, this half plane right here. This is the one that's going to get shaded in. We can fill in our blanks here. The test point 0, 0 is a solution of inequality. So we're going to shade the half plane that includes 0, 0, which is what we did. So let's interpret the solution. Notice that there are infinitely many solutions of the inequality. Because buying fractional bottles of water or sports drinks is not reasonable, only the solutions in which both x and y are whole numbers are viable. Because we can't buy half of a bottle of water. So one viable solution is 10 bottles of water and 8 sports drinks. Next up, we're going to do example 4. Last example, we're going to write a linear equation from a graph. So here we have to do a little more work. I have the graph, but I don't have anything else. I can look and see that I have a point right here, 1, 1. I also have a point right here, 3, negative 4. Those points fall on my line. I can use those points to create an equation. I'm going to do that by first finding the slope. So I'm going to go negative 4 minus 1 over 3 minus 1. When I do that math, I'm going to get negative 5 over 2. Here is my slope. That is my m. Next, I should probably put it in point slope form in order to get it into an equation. So I've got y minus y1 equals m times x minus x1. There's my point slope form. Let's go ahead and use the easier point. I'm going to use 1, 1, and I'm going to use my slope. So y minus 1 equals negative 5 over 2 times x minus 1. I've plugged my point in. Now I need to try to solve. Distribute negative 5 over 2x, negative 5 over 2x, and then negative 5 over 2 times negative 1 is going to give me positive 5 over 2. I'm going to bring this other stuff down because I haven't used it yet. I now need to get y by itself, so I need to add 1 here. Plus 1, plus 1. Y is now going to equal negative 5 over 2x. So the 1 I'm adding is 2 more to this because 2 is the whole. So 5 plus 2 is 7 over 2. So there's my equation, but remember I'm trying to write an inequality. So now I have to determine the appropriate inequality symbol. So I can see where it's shaded. It's shaded down below, right? So we're going to say y, instead of being equal, y is, it's underneath the line. So y is actually less than, because it's underneath the line. It is a dashed line, so that's how we know that it does not have the is equal to underneath. So we have to use the less than, and let's rewrite the whole inequality. Y is less than negative 5 over 2x plus 7 over 2. There is the inequality. Lastly, you have a check where you're going to try this on your own. Try that check now. I can see here that I have a point right here, which is 0, negative 1. So 0, negative 1. I need another point. I see a point right here. That is 1, 2. So 1, 2. I'm now going to use that, and I'm going to find my slope. So I've got 2 minus negative 1 over 1 minus 0. 2 plus 1 is 3 over 1, which gives me m equals 3. I'm going to use my first point, and I'm going to plug it into point slope form. y minus y1 equals m times x minus x1. Let's go y minus y1 is -1, so +1 equals my slope is 3 times x minus x1 is 0. So here we go. 3 times x is 3x. 3 times -0 is just 0. Bring down everything else. For here, I need to get y by itself, so I'm going to go -1 minus 1. Y equals 3x minus 1. There we go. Can't use my equal sign. It's a solid line, so I know I'm going to have an is equal to with it, but the answer lies above the line, so I'm going to have y is greater than or equal to, and then I'm going to rewrite y is greater than or equal to 3x minus 1. And there's the inequality that represents this graph.